Okay, I'm giving this 3-question little quiz as sort of a review today because the test is coming Thursday and I want to make sure you know what's going on. This is a problem from yesterday and the day before about quadratics. I suggested that you want to make sure you give me a range kind of answer, like an interval between -infinity and 5 or something like that. Okay? And I would recommend you always start your questions by saying if you can factor it, you should. All right, number 2. This one, the only complaint I got last hour was somebody felt like it wasn't detailed enough. Let me tell you, how can you determine the number of solutions for a quadratic? What I told them was that the answer lies in the quadratic formula. But there's a thing in the quadratic formula that we described that tells you whether or not, or how many answers it's going to have. It'll tell you if it has 1 answer or 2 answers or no answers. Hopefully you remember that thing, because that's problem number 2. And you need to be detailed. How can you tell if you have 2 answers or 1 answer or no answers? Problem number 3. Problem number 3 is find the vertex. And you're going to do that by completing the square. That's the kind where you take the 11, you move it over, and you ask the little German boy for some help on figuring out the next number. Okay. And then, after complete the square, try this method. X equals some fraction. There's a little thing buried in the quadratic formula that tells you how to find the vertex. Remember that little formula? If you do, then you got half the credit just for remembering the formula. X equals something over something. It's from the quadratic formula. Once you know that formula, actually use it on this to tell what the vertex is. So we're going to complete the square to find the vertex. We're also going to use this little formula that I'm trying to test you on to see if you remember this little mini formula that's built into the quadratic formula that tells you the vertex. Do it both ways. 1 point for complete the square, 1 point for using the little mini formula. All right, so I'm going to leave this. Copy number 1 down real quick and get going on it. X squared plus 2x plus 1 greater than or equal 0. And now I'm going to leave it like this. I'm going to give you about 5 minutes to work. This is going to get graded and put into the 15% category. Yes, sir. You do not have to do an example on number 2, but you have to tell me how can you tell where there's 2 or 1, or you have to be clear about how can you tell how many solutions there are. All right, here we go on solutions. On the first one, if I had just said equals, do you get, I could have just factored it like this, x plus 1 and x plus 1, and said equals 0, and so the answer is x equals -1. I'd have been done if it had been equals. That would be an easy guy. Okay. What happens if it's greater than is you still want that -1, but you're doing this. You're trying to find where is that -1. It's right here. And what is it in the context of the graph? It's a parabola, so what is that spot? It's the minimum. Very good. It's also known as the vertex. How do I know it's the vertex? Because it's the only kind where if there's only 1 answer, remember from the b squared minus 4ac that we're going to do down here, if there's only 1 answer, it is the vertex. Anyway, if you had graphed this picture, that'd be a good way to do it. And then you say to yourself, where is the parabola, that black parabola right here, where is that bigger than 0? Well, it's bigger than 0 or equal to 0 everywhere. It works in here, it works there, and it works in here. So it's all real numbers. -infinity to +infinity. All right. Now, I know that was probably a gotcha for some people, but they probably even knew that -1 was important, but they didn't know how to finish the deal. Now you see how you could have done it. You could have either graphed it this way. Option B, didn't even have to graph it. Didn't have to do this at all. You could have just said -1's important and used a regular number line, and then test around it. If you test -1 itself, will -1 work? Yes. -1 ends up making it equal to 0. And that is equal to 0, so it works there. You could have tested something bigger than -1, like 2. You stick in a 2 here and a 2 here, you'd get positive times positive makes a positive answer, which is bigger than 0. So it would have worked out here. And then last but not least, you could have tested something smaller like -2, and would have found that this becomes negative, and this becomes negative. Negative times a negative makes a positive, which is bigger than 0. It works everywhere. So negative infinity to positive infinity. That's 2 ways you could have done the problem. Yes? Is that a question? If they just said the answer was -1, they are wrong. They had to have the final answer, which is the negative infinity to positive infinity. It works everywhere. Yes? Okay, but I saw what he wrote, and it wasn't that. Okay, so number 2, can you determine the number of solutions for a quadratic? How, or it actually says, how can you determine it? And it's this, b squared minus 4ac, and, do you have a question already? How about you wait till I'm done explaining it, okay? So, I was saying that you could either have this, b squared minus 4ac, or you could say the name for that, which is called the discriminant. They can have half credit just for saying discriminant or b squared minus 4ac. Yes? Yeah, that's pretty close. So I'm going to give it, then I would consider it a spelling error at that point. I don't mark down for spelling. Okay, so how do you actually tell how many solutions it has? The only way you get the other half the credit for this is by saying, if this is greater than 0, you'll have 2 solutions. If it's less than 0, you have no solutions, or no real solutions anyway. If they got really fancy, then they'd say that there were 2 imaginaries. And if it's equal to 0, then there's 1 solution. If they have all of that, they can have the full 1 point. Yes? Did they say anything about b squared minus 4ac? Did they say the word discriminant? Then they have to get half off. But if they had the other half, which is greater than 0 is 2, less than 0 is none, equal to 0 is 1, they can have that half. All right, yes? Okay, so if there's 2 halves to this, this part, or saying discriminant, is half the credit. This part, or describing, whether it's greater than or less than or equal to 0, is the other half the credit. They either get 1 half of it, or they get both halves wrong, which is obviously all wrong. Yes? That's the creative one. No, there's no such thing. Greater than or equal to -1 is not a thing. What? Greater than or equal to 1 is still not a thing. It's got to be greater than or equal. The comparisons are greater than 0, less than 0, or equal to 0. Those are the 3 things. The person will be happy to have it marked wrong now because they're only losing half the credit, right? And they're going to say, I'm so glad I learned that for my test, and I won't make that mistake when it really counts in the 85% category. Yes? Good question. I would accept 1 double solution. That is acceptable. There is 1 solution, but it is true that to some extent it's like a double root. So I like that they included that. That's good. Okay, next part. Complete the square. Here's how it works. For those of you that don't remember, you say x squared plus 4x. You move the 11 over here. You ask the little German boy, how do I do this again? He goes, half square. Half of 2 is 4, or half of 2 is 2, 2 squared is 4, plus 4 and a minus 4. And then this part right here becomes x plus 2 quantity squared. That part right there becomes plus 7. Some of you are talking, please don't. It'll make it go slower. And I'll get frustrated with you. -2 comma 7, of course, is the vertex, but I did say find the vertex. If they got all the way to here, I'm going to accept their answer as okay. But I really did want them to say the answer to the vertex was -2 comma 7. All right. Then, doing it this other way, did you know it was x equals -b over 2a? How many of you knew that yourself? Okay, good. If you didn't know that, write it down or something because you need to know that. Then, what is -b over 2a in this case? It's -4 over 2 times 1, which is -4 over 2, which is negative 2. If they showed all of this work but didn't actually do this, I'm okay with that as long as they showed all their work. They didn't have to have the equation written out. They could have shown the work for it. And then the final answer is negative 2 comma 7. If all they did was negative 2, they didn't actually put the comma 7 there, then they didn't know that finding a vertex implies you have to find the x and the y of it. They lose half the credit. That's a big deal. Yes?
They didn't show the work plugging the negative 2 into the
Did they have the x equals negative b over 2a there? Then they get that half. And it's either this or this. Both is great.
But they didn't plug in the negative 2 to the full equation.
I get what you're saying. Did they have the whole answer? Yes, they're okay. I agree that you need to plug in the negative 2 into the equation, but a lot of people are going to do that in their head, and I didn't need to see it. Otherwise, I had a lot of arguments on that side. So, yes. They made the same mistake of what? I agree with your analysis of the situation. Any other questions? Okay, now you give them a score out of 4. Now, just so that we have a little more anonymity, how many of you just gave somebody a 4? Raise your hand if you just gave somebody a 4. How about a 3 or a 3.5? All right, cool. Everybody that just got a 3, a 3.5, or a 4 is going to get an A on this. And that's because I'm going to not grade it out of 4. You're going to leave your scores out of 4. Just leave them alone. I'll do the adjusting later. I'm just trying to tell you that a 3 out of 4 is normally a 75%, which is actually pretty bad. But in this case, 3 out of 4 is good. It's an A. 4 out of 4 is better. It's going to get a smidge of extra credit. Okay. If you got worse than that, you got some stuff to learn before Thursday then, I guess. All right. Everybody back to your spots. Okay. So this is about linear regression. Well, it can be linear or it can be quadratic. If your data kind of goes down like this and then comes back up again, then you could find an equation of a line that would go pretty much through most of those points. You couldn't get it perfect. In the real world, it's not going to be perfect. That would be quadratic regression. All right, how about this? What if we did time in the weight room, actually lifting weights, just to clarify, because you could be reading a book in there and you won't get any stronger. Time in the weight room, and this is strength. Do you get that generally, if a person has spent a couple months lifting compared to somebody else who didn't spend any, that there's probably going to be an increase in strength there? And then if over time they spend like many, many months, they might actually not improve for a few months, but then eventually over time, with lots of time in the weight room, you will get stronger. I can't get a straight line to go through all those points, but I can get a straight line that best fits those points. It's called the line of best fit. And that's what you're going for with this, is a linear regression. What you're doing is, like on this point, do you see how it's pretty much right on the line? There's no error at all. It's perfect for the situation. But here it's off a little bit. Understandably, you can't get an equation to match every single data point. It's off however much this is. This is off however much this is. This one's off however much that is. And this is off that little amount. And what you do is you take all the error, how much it's off, you take all those distances and you square them, and you find where you can make that number, the squared number, the smallest possible, and then that's where you put your line. I just kind of drew a line through there that kind of felt right to me. But when you actually, a computer does this and minimizes the error, it might have found that, oh, well, your line was off a little bit. It actually should have been more like right here. And it was close to where I had it, but I was slightly off. Now the calculator is going to do that calculation for you. That's going to be really nice. So grab your graphing calculator. And the first thing I want you to do is get to your y equals screen and clear out anything you have in your y equals screen. Okay? So that's going to just, I have an equation in there. I got to get rid of it. And then if you have any plots that are on like this, hit enter on them and turn them off. The way we can tell if your graphing calculator is working right is we'll graph the line y equals x, something super simple like that. And if you can't see that graph, then something is weird. So then maybe you go to your zoom and do a zoom 6. and then I can see my line. So get it so you can see a standard line y equals x. Everybody check your calculator that way. If you can't get a line of y equals x to work, then you should compare with the person next to you. I'm going to pair you with somebody because I know you'd probably like to get help from me, but there's 30 of you, and if there's like 5 people that all have a tech issue, it slows us down terribly. So I need you to be working with somebody right next to you. So I'll pause while I pair you up. Okay, we've got people in groups, and now I'm telling everybody, even though you just graphed line y equals x, I want you to clear that out. You need to get that clear. There can be nothing in your y1. That's one of the things that really messes up this process is if there's already an equation in there. When we try to put the regression equation in, if there's already an equation, it just says error. Okay, so now we go under stat. Under stat, there's 3 choices. We're doing statistics, of course. That's why it's stat. There's editing your data. This is like where you put the data in. There's calculating things like regressions. REG stands for regression. And then there's tests. And there's this tests is where you do a lot of stuff in the actual class called stats. This is just a little taste of stats. This is not the real thing. You'd have to take a class called stats. It's also buried in HL, which is one of the options for you for next year, is they learn a bunch of stats in that class in HL. It's one of the ways you can take calculus next year. So anyway, moving back to edit. Everybody hit enter on edit. And I'd like you to copy down this data. I know it's small on my screen, so I'm going to show you where it is. It's right here. It comes off this slide. If you go down a couple pages, copy that data into L1 and L2. Okay? So there's both of them side by side. 1950, 1960, 1970, etc. I'm going to pause for a second while you load that data in. All right, so here is our data. Now, what do we do with it? Well, the first thing we can do is plot the data. Now, let's think for a second. If I just go to plot, which is above the y equals, and I were to plot this, my numbers generally run from 1 to 10. Do you get that this standard window is not going to be holding 1950 on it? If I just go to graph, you won't be looking at the right part. You have to change your window. So let's go to stat plot first. We'll just get the stat plot going. Under stat plot, which is right above the y equals, remember that when we're done with this, it won't work yet because the window isn't right. We'll fix the window later. Hit enter on the first stat plot, and the first thing you do is turn it on. You want the on to be darkened in or selected. Now down here, you actually can graph it a number of different ways. I would recommend the first one because it'll just be dots. That's what we want. Next thing is your list. I want this to be L1 for X and L2 for Y. This you could make them be little plus signs or little boxes to match the picture that we have on the slide today. I'm going to use little boxes. And color, well, that's a new thing. They didn't used to have color options on these, but don't really care what they use for color. I'm going to hit enter and move down to oh, that's right. On this, you think there's some way you have to hit enter to like be done. You're just done. You're already done. Now we can go to graph. Now the reason it's not graphing is because right now it's only showing from 1 to 10 in both directions. Do you get our data wasn't even close to that? So now we got to go to the window. Everybody go to window. What's the X min? For our X's, what was the smallest one? The X's, 1950. But I'm going to say, let's go with 1940. Always better to give your data a little bit of room to breathe. Otherwise, you might miss a point at the very bottom of your graph. The X max, the biggest X. 2000, but let's give it a little room to breathe, so maybe 2010. Now, the scale we should count by, always count by ones. X scale 1. Y min, the Y data. The Y is the energy usage in quads. The smallest number we have is 34.6. Give it a little room to breathe, maybe 30. And the biggest number we have in the X, or the Y's, sorry, is 98.9. Let's make it 105 or something like that. 110, whatever. Always count by ones there too. Always use a resolution of 1 or whatever the res is. I never even have changed it. But okay, now if I go to graph, you will see your dots. Raise your hand if you had success. Okay, good. Now, how do we make the equation for the lines, for the line that will go through those points? Okay, to make the equation for that line, that is called a linear regression. Does anybody remember where it was? There was a spot we went past. Yes, sir? Under stat, correct. And then calc is correct. And then which one of these? Number 4 is the lin reg. Now, if yours looks like mine, lucky you. I'll be able to walk you through it exactly because it looks just like mine. If yours just says the top thing, lin reg ax plus b, raise your hand if yours is different than mine. Okay, for you guys where it's different, here's exactly what you type right now if yours looks different than mine. Yours won't have this. What you have to tell it is the same stuff though. You have to tell it L1, comma, and where's L1? L1 is down here above the 1 key. L1, comma, L2, that's where you're getting the second piece of the data, and that's right here above the 2 key. The comma is above the 7. L1, comma, L2, comma, again, this is for the people that are different than me. I'll show everybody that's got the same thing as me, I'll show you that in a second. Comma Y1. Now the Y1 is a capital Y1, and here I'll show you where it is. It's under this key right here called vars. That stands for variables. Okay, so I'm now going to show you where Y1 is. Under vars, you want the thing called Y vars. Do you see it? You arrow to the right. You see that thing called Y vars? Under vars, it's Y vars. Then you hit enter, and then there it is, Y1. Okay? That's where Y1 is. So you want L1, comma, L2, comma, Y1. Then you hit enter, and presto, it should have worked. Now, if it didn't, you typed something wrong. You should try it again. L1, comma, L2, comma, Y1. All right, for those of you that where it's like mine, you need an L1 in the first blank. For a lot of you, it'll probably already be there. They need an L2 in the second blank. Frequency list, we don't care. We skip it. Store the regression equation. That one makes sense for where we're going to store our equation under Y1. That's where we want it to put the equation for us. Store regression equation, that's where the vars comes in. Vars, Y vars, enter, enter. Yep. Get the Y1 in there. Now you have to go down. You might think you're done, but you're not. On this screen, you have to hit the thing called calculate. I missed that last hour. Hit enter on calculate, and boom, it calculates it out, and there is my regression equation. And even better, if you hit y equals, it already typed it into the Y1 for you, so you don't have to copy it down and put it all into your Y1. Please first ask the people in your group, because they're often smarter than I am. See if they can figure it out. All right. All right, I'm back with you. Everybody's here now. So, oh, I'm pausing again. Okay, so now you've got an equation. What can you do with it? Well, the cool thing about an equation like this is you can predict. Like, for instance, let's say we needed to know in the year 2010, how many quads are we probably going to be using then? Okay, well, by now, obviously, we're quite a bit. We're in the year 2015. 2015. Let's figure out how many quads we're predicting to be using in 2015. So basically, do you get I just gave you an X? And I want to know what? Y for it. So I go to my table. Everybody do table for this one. Table's way better than graph for this one. And I just look up 2015. Mine's counting by something weird. I'm going to go back to my table settings. And if your table is starting at something weird like mine, get it to start at maybe the year 2000, well, what did I want to know, 15? I'll just go right to that. I'm going to start at the year 2015 and count by ones. Make sure your table setup is right if your table looks all squirrely. There we go. In the year 2015, we're going to use 119.7 quads. How many of you got the same thing? If your data is different than mine, it's because you probably typed one of your numbers in wrong. All it takes is type in one number wrong. This is kind of a deadly thing on a test too. You're going to have to type in like 12 points, which means like 24 entries. You type one of them in wrong, and your equation will be off, and your answer will be off, all because of typing in one number wrong. So you really want to double check your data if you're on a test situation. Okay, so how about conversely, they say energy usage in quads, if that ever gets to 130 quads, we're going to have to build another power plant. So what year might it hit 130 quads? We'll take a look on the table. I can see it. It's jumping right out at me. 2023. So in the year 2023, we better have another power plant up and running because we won't have enough power being created. Did you know that in China, they're putting a new power plant online every 3 days? I want you to process that for a second. Every 3 days, they have a new power plant built. Every 3 days. Every 3 days. Every 3 days. Doesn't that seem insane? It's just they got so many people. And they've had a lot of people that haven't had power. You know what I mean? Out of their population, a lot of them haven't had it before, and they want it. And so they got to build another power plant. Got to build another power plant. Yes, sir. It's a good question. I don't know how many the U.S. is building on average each day. I don't know that number. It's a very valid point. Oh, no. Maybe we're the same, but I doubt it. Because we already have, the vast majority of our population is served by electricity already. And I do think our electric usage is probably going up, just because we seem to be using more and more electronic type stuff. But yes.
So how do you do it again for if like 2022 is 129.3 and then 2003 is 131.1?
Are you trying to try to figure out how to get this table more accurate so you can find out if it's between 2 years or something?
Yeah, it's like,
Okay, so let's say you wanted to 129. Is that what you mean? Like, see how it's 128 and it goes to 130? Where is 129?
like when you ask a question like what year this happened.
Yep. I gotcha. If you want to be a little more specific like that, here's how you would do it. Do you get that we're in the neighborhood of the year 2023 then? This maybe 2022. Okay, so let's talk about where would 129 be? It's not even on my table. Do you get it goes from 127 to 130? How do I figure out where 129 is? You want to make your table more accurate. So let's go to the year 2022. So everybody go to table settings and start in the year 2022, 2022, and count by 0.1s. Do you get how it's going to make the table only go up a little bit at a time and you'll be able to catch things better? If you count by 0.1s there, now I'm going to go to my table. And it starts in the year 2020, and I can see exactly when 129 came around. 129, oh, actually, I probably should count by 0.01s, which would be really painful, but I can see it basically happened in the year 2022. It's just a question of whether it happened in 2022 in like 2/10 of the way into the year, or, see what I mean? And I wouldn't ask you to be that accurate. I would ask you, was it 2022 or was it 2023? And it was definitely 2022 that happened, because if we were talking about 129 rolling around, it was somewhere in here, which is definitely in the year 2022 point something. So to make your data more accurate, you can go to table and change table settings and change the table settings to count by 0.1s. It's actually kind of a pain. So I would change it back right now. Everybody go to your table settings again and get that changed back to counting by ones, because 9 times out of 10, you only want it to be counting by ones. Otherwise, your table, you have to hit down arrow like 5,000 times to get an answer. Okay, so that's a walkthrough, and I want to make sure you get one other important thing. When I look at this equation slope, the regression equation, I'm going to go back to stat where I had that. Stat, calculate the regression, and this is going to be good enough. So I go, I should put a y1 into, put it in my y1 equation, but there it is. Do you get that that slope right there is not talking about the number of chickens in China? It's talking about the amount of what in what? Energy usage per year. So 1.28 is being positive means our energy usage is doing what? It's going up. Okay. What if the slope had been negative? Energy usage would be going down over time. Okay, so I just want to make sure you get the context of this. The slope, in this case, is talking about energy usage going up. All right, now your actual homework. Everybody find this slide that says exercise, I think. There we go. There's only 2 homework problems that I need you to do for tonight, and they are both regressions. It's problem 2 right here, and don't let it freak you out that it turns the data sideways. Time is always x. I don't know if you remember this rule, but time is the independent variable, and the independent variable always goes on the bottom of a graph, and that's where the x-axis is. So the time needs to be the x. Okay? So then the population, that must be the y. This, therefore, is the L1, and this, therefore, is the L2. So if you put that data in your calculator, remember that your calculator is going to automatically default to the problem you did last for its window. The years are pretty close to the same on this, so we won't have to worry about the x numbers, but do you get that the y numbers used to be like 35, and now the y numbers are huge? So you're going to have to, when you type this data in, to be able to see it on the graph, you'll need to go to your window and change the window so that you're going in the neighborhood of 250,000 to 290,000 or something like that. Change that window so you can actually see the graph. All right, so there's 2 regression problems. That one and that one, that's all you need to do. I know there's other questions. You do not need to do the other questions. Stay caught up with this. You don't want to get behind. We're getting really close to a test. The test is coming on Thursday. Tomorrow, I'm going to just touch on regressions a little bit, and the rest of the hour will be review. And that's all I have for you for today.